Good day, my dear students. Welcome to another session in Mathematics 9. So we are now in Quarter 3, Week 2, Melc number 3. Under Melc number 3, we have the topic proves theorems on the different kinds of parallelograms: rectangle, rhombus, square. This module was made to help you understand better the theorems on the different kinds of parallelograms. It will serve as a guide on the different kinds of parallelograms: rectangle, rhombus, and square. Let's define first what is a rectangle. A rectangle is a quadrilateral with 4 right angles. Theorem number 1. If a parallelogram has one right angle, then it has 4 right angles and the parallelogram is a rectangle. We have here an example. Given, rectangle 1 is a parallelogram with angle J is a right angle. Prove that angle U, angle A, and angle N are right angles. So we have here the representation or the figure. We have angle J, angle U, angle A, and angle N. So it forms a rectangle. We have here the statements and the reasons on how to prove the given problem. So in number 1, rectangle 1 is a parallelogram with angle J is a right angle. Reason that is given. Number 2, measure of angle J is equal to 90 degrees. Reason, by definition of right angles. Number 3 statements. Measure of angle J is equal to measure of angle A, and measure of angle U is congruent to measure of angle N. Reason, number 3, in a parallelogram, opposite angles are congruent. Number 4 statement, measure of angle J is congruent to measure of angle A. Measure of angle U is congruent to measure of angle N. Reason, by definition of congruent angles. Next, number 5, measure of angle A is equal to 90 degrees. Reason, by substitution. Statement number 2 and number 4. Number 6 statement, measure of angle J plus measure of angle U is equal to 180 degrees. Reason, consecutive angles are supplementary. Number 7 statement, 90 plus measure of angle U is equal to 180 degrees. Reason, by substitution in statement number 2 and number 6. Number 8, measure of angle U is equal to 90 degrees. Reason, subtraction property in statement number 7 and 8. Next, number 9, measure of angle N is congruent to or equal to 90 degrees, and the reason is by substitution in statement number 4 and number 9. Number 10 statement, we have angle U, angle A, and angle N are right angles. And the reason, we have if the measure of an angle is 90 degrees, then it is a right angle. Therefore, in our statement number 11, rectangle 1 is a rectangle by definition of rectangle. So that is an example for proving a rectangle. Theorem number 2. The diagonals of a rectangle are congruent. Example, we have the given. One is a rectangle with diagonals, line segment JA and line segment NU. We're going to prove that line segment JA is congruent to line segment NU. So here is the figure. We have the angle J, angle U, angle A, and angle N that forms a rectangle. Okay, we have the following statements and the reasons. Number 1. One is a rectangle with diagonals, line segment JA and line segment NU. The reason is by given. Number 2. Line segment JA is congruent to line segment UA. And the reason is opposite sides of a parallelogram are congruent. Number 3. Angle JNA and angle UAN are right angles. And the reason, by definition of rectangle. Number 4 statements. Angle JNA is congruent to angle UAN. And the reason, by definition of right angles. Number 5. Line segment NA is congruent to line segment AN. And the reason is by reflexive property. Number 6. Triangle JNA is congruent to triangle UAN. The reason is by SAS congruence postulate. And for number 7, line segment JA is congruent to line segment NU by CPC-TC. So that is the example for proving a diagonal in a rectangle. Next, let's move on to rhombus. So let's define what is a rhombus. A rhombus is a quadrilateral with 4 congruent sides. We have theorem number 3. The diagonals of a rhombus are perpendicular. Okay, let's have an example for rhombus. Given, rhombus PEDR, and prove that line segment PD is perpendicular to line segment ER. So we have here the figure. We have the angle P, angle E, angle D, and angle R. That forms a figure of a rhombus. Okay, we have the following statements and the reasons. Number 1, rhombus PEDR. Reason is given. Number 2, line segment OP is congruent to line segment PE. And line segment ED is congruent to line segment DR by definition of rhombus. Number 3, line segment ER is congruent to line segment RE by reflexive property. Number 4, triangle RPE is congruent to triangle EDR by SSS congruence postulate. And number 5, angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4 by CPC-TC. So that is the proving of a rhombus. Next, we have a square. So let's define what is a square. So a square is a quadrilateral with 4 right angles and 4 congruent sides. The square is the most special parallelogram because all the properties of parallelograms and the theorems on rectangles and rhombuses are true to all squares.